Okay, so this is a second example. This one, there's not going to be so much cancellation happening, so we're not going to get a single variable in one go. So we're going to have to be dealing with a couple more eliminations this time. So we have these three simultaneous equations. And again, as per normal, I'm going to give them all numbers or names. So 1, 2, and 3. Then I want to pick a variable to eliminate. So again, here, realistically, we could pick either one. So in that case, I'm just going to pick Z to eliminate. Of course, we could do X or Y equivalently. That's okay. So let's consider pairing up equation 1 and 2. Now, 1 has the bigger coefficient, so that's going to be left alone. So 3x take away y plus 2z is equal to 10. And equation 2, we want some form of 2z popping up. So what we're going to do is we're going to multiply that by 2 because we want a minus 2z there. Then after that, we just multiply everything else by 2. So in equation 2, we're going to get 4x plus 6y is equal to 10. So what we're going to do is, because we have different signs, we're going to add the two of them. So those two are going to get knocked out, leaving us with 7x plus 5y is equal to 20. Now, just to keep the notation consistent, I'm going to call this equation number 4. Okay, now we're going to move on to comparing, say, 2 and 3. So 3 has the bigger coefficient, so that's going to go on top. So we'll get x plus 4y minus 5z is equal to 3. And considering we want the z's eliminated, let's multiply the second equation by 5. Again, that'll give us a 5z where we want it. And now we just have to multiply everything else by 5. So we'll get a 10x plus 15y minus 5z is equal to 5 lots of 5, which is 25. Now, because they have the same sign, we're going to subtract the two of them. So these two are going to knock each other out. We're going to get negative 9x minus 11y is equal to negative 22. So flipping them around, we get 9x plus 11y equals 22. And that we can declare as equation number 5. So great, we've now gotten to a point where we essentially have a two variable simultaneous. Now, the logic I'm going to use here is going to be the same if we were doing 3 variables if we're in this immediate process, where we don't have any of them equaling 1, and if I were to divide through, then it would just make the process a little bit weird. So if you can't get it to a point where one of them simplifies to 1, or the coefficient simplifies to 1, here's the trick I'm going to do. Firstly, we're going to pick a variable that we want to be the same. In this case, let's pick the y's. What we need to do is pay attention to the coefficients. So in this one, we have an 11y, particularly in equation 5. And if we multiply that by 5, that'll give us a 55y. And similarly, if we take equation 4 but instead multiply it by 11, so take this equation and multiply it by the other coefficient, we're also going to get a 55y, and both of them happen to be positive 55y. So that's essentially the strategy. So you multiply one equation by the coefficient of the other. So this 11 comes from here, and this 5 comes from all the way up here. So taking the rest of equation 4 with us, 7 times 11 is 77. And 7 times 20 is, 11 times 20 is 220. And then 5 times 9 is 45. And then that's going to be 110. So because they have the same sign, we're going to subtract, so they knock each other out. And we're going to have to need a calculator for this. So we get 32x is equal to 110. Yeah, we're not really going to get nice answers here either. We get x is 55 over 16. Okay. Then all we have to do is just double check, or not double check, but, well, sub that back in to get y and z. I'm not sure why I said double check there. So the way I tend to notate this is by writing down the equation number sort of next to an arrow. So I'm going to substitute that into the unedited version of equation 4, because that's the one with the lower coefficient. So what equation 4 is now going to read is 7 times x, which is 55 over 16, plus 5y equals to 20. So we get 385 over 16 plus 5y is equal to 20. So 5y is negative 65 over 16. So dividing that by 5, we get y is minus 13 over 16. And now with that information, we can sub into any of the other equations. Now, ideally, because we want z, let's sub into equation 2 to save us on a little bit of multiplication. So what equation 2 is now going to read is 2x, which is 55 over 16, plus 3y, so that's plus 3 times minus 13 over 16 minus z is equal to 5. So 2 lots of 55 over 16 plus 3 lots of minus 13 over 16 is 71 over 16 minus z is equal to 5. So z is minus 9 over 16. So the solution in xyz form is 55 over 16 minus 13 over 16 and minus 9 over 16. Now, I'm pretty sure that's right, but if I made a mistake, obviously please do let me know in the comments. I am human, and these questions do take a good bit of time and require a lot of concentration. So screw-ups are pretty much inevitable. So best to get good at practicing them.